So good morning to all of you. How's your vacation? Happy New Year to all and I hope you enjoyed your holiday season. But now we're back to reality and today is the beginning of new chapter in science. So in second quarter, the branch of science that we are going to deal with is all about chemistry. But what is chemistry? Do you have any idea what chemistry is all about? So for today, we are going to know the answers to those questions as we go along with the following topics. So our module number 1 is entitled In Search of Negatives. And this module is anchored on the division made module from SDO Caloocan. The most essential learning competency is to explain how the quantum mechanical model of the atom describes the energies and position of the electrons. The expectation that we are going to have today are the following. First, trace back the history of an atom. Second, be familiar with the scientists who made some contribution in the development of an atom. Third one is to explain quantum mechanical model and describe the set of quantum numbers. Fourth, we have using periodic table in identifying the symbol and electrons of the elements. And last one, supply the following data from the electron configuration such as the period number, group number, and number of valence electrons. So what is chemistry? Do you have any idea what chemistry is all about? In what way do you think that chemistry affects our daily lives? So let me help you answer this question and understand the significant study of matter. So chemistry, the study of matter, its composition, properties, behavior, and the processes and chemical reaction they undergo. Chemistry is linked with other natural sciences like biology, geology, and physics. Chemistry has significant impact in our daily living. From the moment you wake up until you go to bed, you encounter chemistry, like the things you use while taking a bath, such as shampoo, soap, conditioner, toothpaste, which contain a lot of elements and compounds. When you cook food and eat, you will see some ingredients in that particular food that you are eating. And perhaps you are wearing some shirts or dresses that are made up of fiber, either natural or synthetic, that have been dyed. These are just some of the examples of our activities every day that most probably connected to chemistry. And medicine. Medicine is a very significant part of our lives, most especially when we or some of our loved ones is sick. And those medicines has been produced and manufactured with the help of chemistry. And to strengthen your knowledge about the importance of chemistry in our daily lives, let us watch one video clip. And please take down important information. After watching the video, let's start with this lesson. Let's study first the history of atoms. But let me ask you this question first. Do you believe in something that you cannot see? I'm asking you this question because in this lesson, the basic components of matter cannot be seen by our eyes. And that fundamental unit of matter is what we call atoms. Atoms which are invisible. So what are atoms? Atoms are a basic building block of matter. And today, let us trace back the history of atoms. When did the idea of atoms came, and who are the people responsible for the development, study, and history of atoms? So, first in line is Democritus. Democritus in the 4th century first proposed the idea about atoms. He was a part of the atomist school of thought. Atomists believed that matter was composed of tiny or small indivisible particles, which was called atoms. So according to Democritus, matter was composed of tiny indivisible particles, and he said that atoms were invisible, indestructible, and fundamental units of atom. Indivisible means that the particles cannot be divided anymore or separated from each other. However, the idea of Democritus were not that useful in discussing the chemical behavior because of the missing experimental support. Because Democritus did not conduct any experiment to test his idea and theories, that is why the connection between the observable chemical changes and event was not developed for 2,200 years. But John Dalton studied chemistry in a different way compared to Democritus. On the contrary, Dalton conducted several experiments to make his atomic theory. But in the first place, who is John Dalton? He was an English school teacher. He studied many different topics in science and performed several experiments to prove his observation. He also formulated Dalton's atomic theory, which include the idea about elements, atoms, and chemical reaction. Dalton was only 12 years old when he got his job as a teacher. He was so much interested in science, that is why he studied so many different topics in science such as the trade winds, the color blindness, the aurora borealis, and his prominent input to science was his idea about atoms in discussing its chemical behavior. Based on the result of his experiments, he developed hypotheses and theories to enlighten his observation, and with these he formulated Dalton's atomic theory. Dalton's atomic theory is composed of four components, and here they are. First, all elements are composed of submicroscopic particles called atoms. Second, atoms of the same element are identical. Third, atoms of different elements can physically mix together or can chemically combine. And fourth, chemical reactions occur when atoms are separated, joined, or rearranged. So many part of Dalton's atomic theory is accepted today. But there is one important revision, and that is atoms are not indivisible. Why do you say so? Let us see the answer in the next slide. Atoms are not indivisible because atoms can still be broken down into smaller and fundamental parts. Atoms are composed of three subatomic particles called the proton, electron, and neutron. Electrons are portion of the atoms of the element. They are the negatively charged particles, which was discovered in 1897 by Sir J. Thompson. It is located outside the nucleus and its mass unit is equal to 0.0005. The symbol for electrons is like this, pertaining to the negatively charged particle. So Sir J. Thompson is an English physicist who conducted many experiments just like the flow of electric current via gases. Another subatomic particle of atom are the protons. Protons are what we call the positively charged particle, which was revealed by Goldstein in 1886. It is located inside the nucleus and it has a mass unit of 1.0073. The representation for proton is just like this for the positively charged particle. And the last one is the neutrons. Neutrons are the subatomic particle with no charge and exposed by Sir James Chadwick in 1932. It is located inside the nucleus and the mass unit is equal to 1.0087. It is symbolized by this. 0 meaning no charge. So let us proceed to the evolution of the modern atomic theory. There are several scientists in the ancient time who studied about atoms and they arrived at different theories on how the atom looks like and what are the particles inside. So let us study those persons one by one. First in line is the Dalton's atomic model. In the early 1800s, John Dalton established the first scientific model about atoms. He understood that all matter was comprised of small particles which are called atoms and cannot be divided into smaller parts. And his theory about atoms looked like this, just like a billiard ball. The second model of atom was proposed by J. Thompson. He presented that the negatively charged electrons were embedded in the ball of positively charged material. This is also called the plum pudding model of an atom in 1904. This is how the model of Sir J. Thomson looks like. This is also called the plum pudding model because it looks like a pudding or a chocolate chip like this. As you can see, the whole cookies represent the atom, while the chocolate chips inside or embedded in the cookies symbolize the electrons. So here, in this model, you can see the positively charged material wherein electrons are embedded on it. Okay, so that is the Thompson atomic model. Another model of an atom was devised by Ernest Rutherford in 1911. What is that? After the discovery of protons, the Thomson model established into the Rutherford model, which pronounces that an atom have a central positive core called the nucleus, which are surrounded by negative orbiting electrons. This model proposed that most of the mass of the atom was concentrated in the nucleus. So Rutherford's atomic model was based on his experimental result. The fourth atomic model was proposed by Niels Bohr in 1913, and he explicated that an atom has a central nucleus enclosed by a distinct energy level wherein the electrons may be located. This model proposed that electrons circle the positively charged nucleus in a spherical orbit. These orbits are called energy level or energy shell. So in this diagram, you can see the Bohr's atomic model, wherein at the center you can find the nucleus, and you can notice that there are some orbits around the nucleus. And this orbits is what we call energy level according to Bohr's atomic model. In this orbit, we can find the electron orbiting around the nucleus. And for the fourth or the fifth is the quantum mechanical model. In 1926, Erwin Schrödinger, an Austrian physicist, used the quantum theory to write and solve mathematical equations to show the position and electrons' energy in an atom. This is called quantum mechanical model, which is called the wave mechanical model. It is developed by Louis de Broglie, Erwin Schrödinger, and Werner Carl Heisenberg in 1926. Later on, this model defines the electrons using the uncertainty principle. The quantum mechanical model defined the atom as having a central nucleus surrounded by electrons located in the regions with high probability, which is known as the electron clouds. So the quantum mechanical model is exclusively mathematical compared to the first four atomic model that I have presented. The quantum mechanical model does not define the definite or the exact location of the electron around the nucleus, but instead it projects the probability of locating an electron in a particular area. The probability of locating an electron within a specific area around the nucleus can be presented by a fuzzy cloud, just like this picture. Here you can see the darker area indicates the high chance in locating the electron here, but the lighter area here shows the low probability in finding the electron. So meaning to say, if the cloud is most dense, there will be a high chance of finding the electron, like here, the darker one. When the cloud is less dense or lighter, there's a low chance or low probability of finding the electron. Take note that each electron has a set of four quantum numbers which show the most probable location of the electron inside the atom. So we will now proceed to the four quantum numbers, which are the N, L, ML, and MS. First in line is the principal quantum number, which is symbolized by letter N. Quantum mechanical model assigns energy levels by principal quantum numbers. It is very significant to note that not all electrons are positioned the same distance from the nucleus. The order is increasing as the value of n increases. The distance of electrons from the nucleus also increases. Electrons are located in some regions in the nucleus, which is called the shell or principal energy level. In each principal energy level, the electrons take up energy sublevel with a specific type. In a quantum model, the cloud shapes where electrons are most likely to be found is called the atomic orbitals. These atomic orbitals are denoted by the s orbital, which look like this. The p orbital, which is represented by this diagram, the d orbital, which is this, and the f orbital, which look like this. So all in all, we have four types of atomic orbitals, the s, the p, d, f. Atomic orbitals are the mathematical description of where the location of the electrons are inside the atom. So this table presents the summary of principal energy level, sublevel, and orbitals. So here you can see the principal energy level, which is equals to 1, we can find one sublevel there. And the type of sublevel is the s, or the s orbital. If n is equals to 2, the sublevel number is 2. So we have two types of sublevels, which are the 2s and the 2p. If n is equals to 3, the number of sublevels are 3, which are the 3s, 3p, and 3d. And if n is equals to 4, there are 4 sublevels, which are the 4s, 4p, 4d, and 4f. So as you notice, the principal quantum number, which is symbolized by letter n, is equal to how many sublevels are there in that particular energy level. Like this, n is equals to 1, so 1 and 1 sublevel. N is equals to 2, there are 2 sublevels, and so on and so forth. So just so you know that orbital we have are 4. The s orbital, the p, the d, and the f orbital. In the s orbital, in the s, there is only one orbital, which means that there is only two maximum number of electrons that can occupy the s. Because in each orbital or per orbital, there could be 2 electrons. Not 1 but 2. So it cannot have 3, 4, 5, only 2 per orbital. So in P, we have 3 orbitals. It means that the maximum number of electrons that can occupy the P is 6, because 3 times 2 is 6. In the D, there are 5 orbitals present, which means that the maximum number of electrons are 10. And in F, there will be maximum number of electrons that can occupy the F, which is 14, because there are 7 orbitals in the F. Okay? So the principal energy level is divided into sublevel, which is known as the subshell. And each subshell comprises of one or more electron orbitals. This second quantum number is used to designate the sublevels inside the atom. This also describes both the number of subshells and the type of orbital in a particular energy level within a given subshell. So take note that N, or the principal energy level, is related to the second quantum number, or the L. Or in other words, the first quantum is related to the second quantum number, because the values of L is dependent upon the value of N. So here we go. If the value of L is 0, the type of orbital that you can see is the s orbital. If the value of L is 1, there will be p orbital there. If the value of L is 2, d orbital is what you're gonna find. And if the value of L is 3, there will be f orbital. So another information is this. Like what I said a while ago, N and L, or the first and second quantum number, are related to one another, because if N is equals to 1, the value of L is only 0 and the sublevel is only 1. If N is equals to 2, there will be two values of L, which are 0 and 1, and that means there are two sublevels. If n is equals to 3, the values of L are 0, 1, 2, which is equal to 3 sublevels. If n is equals to 4, there will be 4 values of L, which are the 0, 1, 2, 3, which means 4 sublevels. If n is equal to 5, there will be 0, 1, 2, 3, 4, 5 values of L, and that is equal to 5 sublevels. And then if n is equal to 6, there are 6 values of L, which are the 0, 1, 2, 3, 4, 5. And that will be 6 sublevels. If n is equal to 7, the values of L are 0, 1, 2, 3, 4, 5, 6, which means that there are 7 sublevels. So the principal energy level here, which is symbolized by letter N, is divided into sublevels, which is the second quantum number, because the second quantum number designates the sublevels inside the atom. Okay, so the second quantum number is symbolized by letter L, while the first quantum number is symbolized by letter N. And in each N, or in each first quantum number, there is equivalent value of second quantum number. So there will be equivalent value of L to N. That's why they are related to one another. So here we have the third quantum number, which is symbolized by ml. It is defined as the spatial orientation of each orbital. So, like how first and second quantum number are related to one another, the second and third quantum number is also related to one another. Because if L, which is the second quantum number, is equal to 0, the value of ml is 1, and the type of orbital is s. If the value of L is 1, p orbital is the type of orbital that you can find, and it will start with -1, 0, then +1. So just like an integer pattern. If the L is 2, the value of L is 2, the type of orbital is D, and we will start, since it is 2, we will start at the -2 followed by -1, 0, +1, +2. And if L is -3, F orbital is the type, and since it is 3, we will gonna start at -3, -2, -1, 0, +1, +2, and +3. So here we have the central core, which is the nucleus, and around the nucleus, we can find the first energy level, which is symbolized by n is equals to 1, followed by second energy level, which is symbolized by n is equal to 2, third energy level, which is represented by n is equal to 3, fourth energy level, which is symbolized by n is equal to 4, and so on and so forth. And for the last quantum number, which is the fourth quantum number, and symbolized by ms. What is that? It is defined as the spins of the electron, and it could be clockwise or counterclockwise. Clockwise spin is equal to +1/2, and it is symbolized by an arrow pointing upward, while the counterclockwise spin is symbolized by -1/2 and represented by an arrow pointing downward. Okay? So let us apply all the knowledge we have learned in the following exercise. First, I will show you how, and then I will give you some seat work later for you to accomplish today that will serve as your performance task. But first of all, you have to be familiar with the periodic table. With the construction of living and non-living things, elements are needed because they are the building materials of all things. They can combine with each other to form compounds, and it will be very important that you can name some compounds, but it will start in knowing some elements. So let's begin. Elements are listed in order of their increasing atomic number from left to right and also from top to bottom. There is what we call group of period, and later you will know what is the difference between the two. So periodic table is also called the periodic table of elements, which arranges and organizes the elements according to their properties. Like for example, we have the hydrogen, helium, lithium, beryllium, boron, carbon, and so on and so forth. The group is the column of elements found in the periodic table, while the period is the horizontal row found on the periodic table. So the column pertains to the group and the period refers to the row. And later, I will give you some example what group and period are all about. And then another information is the valence electron, which are the electron position in the highest energy level, while the core electron pertains to the inner electrons of an atom. Take note that electron is equal to the atomic number and proton number. So let us apply this knowledge and information in the following exercises. But first of all, let me introduce to you the periodic table of elements. So this is how periodic table look like. The letter that you can see like H, HE, LI, BE, BCN, and so on and so forth are what we call the symbol of the elements. For example, we have boron. The symbol of boron, as you can see in the periodic table, is letter B. Okay, so it is symbolized by letter B. That is the symbol. The symbol for neon is letter capital N, then followed by small letter E. So I have here my own periodic table, but you can have your own periodic table. You can buy it to the nearest from the nearest store in your house, or you can download from the Google and print it, because in this second quarter, you really need a periodic table because all of the lessons are anchored in this periodic table. Okay? So, it's like what I'm saying, symbol is the letter that you can find on this table or on this periodic table. They always start with capital letter. And as you notice, on the upper corner of each element, you can see the number. A number like this is what we call the atomic number, and it is also the electrons number of each element. So meaning to say, if B is for boron and there is 5 at the upper right corner, 5 is the atomic number of boron and there is also 5 electrons present in the boron. And electrons is also equal to the proton number, which means there are also 5 protons in boron. Another example is the nitrogen here, which is symbolized by letter N. So, 1, 2, 3, 4, 5, 6, 7. So, now the seventh element in the periodic table is the nitrogen, which is represented by capital N. That's why the atomic number is 7, which means that the electrons are also 7. The proton number of nitrogen is also 7. Okay? Just like that. So the letter symbolizes the is a symbol for the element, and the number pertains to the electron, atomic number, and proton number. How about the column that I am talking about a while ago? So the column here is what we call the group of the element. So column 1 pertains to group 1, column 2 pertains to group 2, column 3 pertains to group 3, 4, group 4, and so on and so forth until group 8. So, meaning to say, hydrogen, lithium, sodium, potassium, rubidium all belong to group 1 because they belong also to column number 1. While the fluorine, the chlorine, the bromine all belong to group 7 because as you will count it, they all belong to column number 4. On the other hand, the period is the row. So period 1, meaning row 1, row 2, row 3, row 4. So the row is equivalent to the period 1, period 2, period 3, period 4. So meaning hydrogen and helium belongs to period 1 because as you can see, they are in the row 1. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they all belong to period number 2 because as you notice, they are located in row number 2 and so on and so forth. So that's how the group and period different from one another. Okay? And also, just so you know that the group is also equal to the valence electron of the element, which means if the element is in group 1, the valence electron is 1. If the element is in group 2, the valence electron is 2. If the element belongs to group 3, their valence electrons are 3. So, it means that the group number of that element identify how many valence electrons are present in that element. Okay? So, take note of the following information because as of this moment, we are going to have our exercise. So, what are you going to do? Just complete the table by filling in the missing data. Of course, I will show you how to do that, and after that, you will be the one to accomplish it. Okay, on your notebook, and just send to me your answer so that I can check if it is correct or not. So this is the table that you are going to answer. I will give you one example first. The element that we have here are lithium, calcium, oxygen, chlorine, and strontium. So you're gonna give me the symbol of the particular elements here, the atomic number, the electron, the proton group, period, and the valence electron in each given element. Okay, so let's start with lithium. So as you will go back in our periodic table a while ago, lithium is symbolized by Li. It is located in column number 1. It is located in row 2. So group 1 meaning and period number 2. So let us see if it is correct. So lithium, as I counted, it is the third element in the periodic table. Since it is the third element, the atomic number is 3, which means the electrons are 3, the protons are also 3. And lithium, as we checked a while ago, it belongs to group 1, meaning the valence electron of lithium is only 1. It belongs to row 2, that's why it is period number 2. How about in calcium? Let us check again our periodic table. That is why it is very important that you have your periodic table with you because we need that. Calcium is the 20th element in the periodic table. How do I know that it is 20th? Because the atomic number is 20 here. And it belongs to 1, 2, 3, 4, row 4 and column 2. So let us see our answer here. So calcium, symbolized by Ca, has 20 atomic number, which means electrons number are 20 also, the protons are also 20. It belongs to column 2, which means group 2, having 2 valence electrons since it is group 2. It belongs to period number 4 or in row 4 oxygen. It is symbolized by capital O, 8 atomic number, meaning 8 electrons and 8 protons. It belongs to column 6, which is group 6, meaning to say there are 6 valence electrons. It belongs in row number 2, meaning period 2. Chlorine, on the other hand, symbolized by Cl, having 17 atomic number, which means 17 electrons and protons. It belongs to group number 7 because it is located in column 7, which means there are 7 valence electrons present in the chlorine. And period number 3 is the row of fluorine. And the last one is the strontium, which is represented by capital R and small r, a capital S and small r, having 38 electrons and 38 protons because the atomic number is also 38. It belongs to column 2, that's why it can be said that it belongs to group 2 also, having 2 valence electron. And row 5 is the location of strontium, meaning period number 5. So I hope it is clear to you how you're going to give or supply the missing data in this table. Because on the next slide, you will be the one to answer. But of course, it is dependent how you understand this exercise that I presented now. So here is your sheet work that will serve as your task today. Just send to me your answer. So your exercise will also the same way that I answered the first table. So just supply the missing data in the table. But first of all, you have to get your own periodic table because you cannot complete this table without the help of your periodic table. So the elements that I will be giving you are the boron, magnesium, sulfur, fluorine, and sodium. So just give me the symbol of these following elements, the atomic number, electron, proton, group, period, and the valence electron. So all the answers here can be found on your periodic table. Okay? So just send to me your answer in the messenger so that I can check if it is correct or not. So that's all for today, and I hope you learned something from our lesson which you can apply in real life situation. Before we end up, take note of the following tasks to accomplish this week, such as the quiz 1 in the Google form for the second quarter, which will be answered in this form. And for your performance task number 1 for the second quarter, which will be answered in the Google Classroom. And for your module, please wait until the school distribute it to you. So for now, you only have two activities to accomplish, the quiz and the performance task. Okay?